In this video, I will go over how to find normal forces. Normal force is the upward supporting or the upward perpendicular supporting force that comes about when two surfaces are in contact, like the box on the floor. The, the floor exerts an upward supporting force on the box that's perpendicular to the floor. So let's draw that in. So the box is supported by a normal force. Fn, and there's also weight force. And because the sum of the forces in the y direction equals zero, the weight force and the normal force must be equal. There's the weight force, there's the normal force. So if you want to find the normal force, it's the up forces on the box, normal force, equal the down forces in the box, and I've just found the normal force. It's 50 newtons. And that's pretty simple. We've gone over things like that before, but it's going to get a little tougher, especially starting on the next problem. So how do you find the normal force? The force of the floor, the supporting force of the floor on the box that's perpendicular to the floor and perpendicular to the box. So this one's not so easy, but we always start the same way. We would find the normal force. Sum of the force in the y direction equals zero. Now, we look at this box and we say not only on the box there's a downward force, that's 40 newtons, but there's another downward force in the box because you see that arrow that represents maybe somebody pushing not completely down in the box, but down and to the right. They're exerting a force that's not completely down. It has a down component that looks like this and a right component that looks like this. We'll call this Fy and Fx. Fx is making the box slide to the right, but Fy is doing nothing. It's just making the box press on the ground a little harder. So all the once again, sum of the forces in the y direction equals zero. All the down forces, well, 40 newtons is a down force, plus Fy, which is 50 newtons sine of that 53.13 degree angle. Those are the two downs. The two down forces equal the one up, which is the normal force. So this is 40 newtons, and the 50 sine of 53.13 is also 40 newtons. And so we find out the normal force equals 80 newtons. All right, so let's go over this again. The box does press on the floor, but not with more than a 40 Newton force because of the vertical component of that applied force. Imagine that black arrow is someone that's just pushing a box across the floor, but they're not pushing it completely horizontally. Their force is a blend of a horizontal and a vertical force. It's got a horizontal component and a vertical component. Okay. Now let's take a look at the third one. Once again, we're going to find the normal force. Get over here. So we start the same way. Sum of the forces in the y direction equals zero to find the normal force. The normal force would look like this. Goes up like that. Remember, it's perpendicular to the box and perpendicular to the surface. That would be the normal force. All right. We're going to use a rotated coordinate system that goes like this, x and y, just to make things simpler. So the sum of the forces in the y direction equals zero. So there's just one up force. That is the normal force. And there's actually just one down force. That is the perpendicular component of the weight force. So that would be 100 newtons cosine of 36.87 degrees. So looking over here, see if I did that right. Yep. When you do the math, it equals 80 newtons. So that's pretty straightforward. You've seen things like that. Why didn't I include this 100 Newton force? Do you recognize that this 100 Newton force only acts horizontally, only acts in the x direction? It is purely an x force and will not, none of it acts in the vertical direction. So that's why last time I included the applied force, the vertical component of the applied force in my equation. This time I don't because I have a completely horizontal force. Okay, so let's scroll down again. And let's do what we always do to find the normal force. What we'll find is the floor's force on the bottom box. I won't do the normal. There's actually another normal force of the bottom box on the top. We could do that, but I'm not going to do it now. I just want to find the floor's force on these two boxes that we consider them as just a box that's 70 newtons. Together they are 70 newtons, so they are pressing on the ground with a force of 70 newtons. All right, sum of the forces in the y direction equals 0. The up force is equal to down. Let's see, there's only one up force, and that would be the normal force. But there actually are two down forces on the box. There's one up force called the normal, and there are two down forces. The first down force is the weight force, but there's also, look at the applied force. The, the applied force doesn't act purely horizontally, it actually is a blend of horizontal and vertical components. So I have to add the vertical component of the applied, we'll call it F1y, the vertical component of this applied force. Imagine it's just a person pushing on the top box to cause the two boxes to slide across. Um, we'll just leave it at that. So we just want to find the friction force down here. So the up force, the up force equals the down force. So the down force is 70 newtons, and then it's 50 newtons sine of 36.87. Yep, 87 degrees. And so the force turns out to be 100 newtons, because this must have been 30. Okay, so that's 100 newtons. There we go. And we'll keep going. These boxes have friction on them, but all we care right now is the normal force on the box equals 0. We have a coordinate system that looks like this. So the up force is equal to down force. Um, let's see, I just see one down force, that's 100 newtons. And I see the up force, of course, would be the normal force. The normal force would act this way, because the floor's force on the box, we'll call that normal. And that's the up force. But there's another up force. Do you recognize this applied force? The force that's put on this box has two components, Fx and Fy. And the Fy is another up force, so it's 50 newtons sine 36.87 degrees. So it's 100 newtons equals Fn, and 50, let me flip the page over. Got all the work done here. 50 newtons sine. So 50 sine 36.87 is 30 newtons. So we see in this problem, the normal force is 70 newtons. Let's look at that again. The normal force is not equal to 100. And the reason why is that this applied force lifts the box up a little bit, because the applied force has a vertical component. The vertical component was 30. So the box doesn't press on the ground with 100. It presses on the ground with 100 minus 30. It's just, once again, ups equal the downs. What was I think I got it exactly wrong. The downs, yeah, equal the ups. The normal is an up, and the vertical component is an up, and the weight is a down. And so that's how we do it. Let's see, we're not going to I think I'll skip the next one. Get this up here. Now let's look over here. I want to find the normal force. Start the same way, equal 0. I have a rotated coordinate system. So the up force is the normal force, and the down force is the F perpendicular, which is 100 newtons cosine 36.87 degrees. That's 0.87 degrees. Let me make that a little neater. 36.87 degrees. 36.87 degrees. That's newtons. So the normal force equals, 80 newtons, I think that is. 80, yep, newtons. So that's my normal force. All right, let's go to another one. Let's go this one over here. This one's an interesting one. Oh, well, let's get back to this over here. Why didn't it seems like I totally ignored this applied force. Imagine this is someone pushing with a force that's parallel to the ground. I ignored the applied force because it doesn't make the box press on the ramp any harder because it's a purely X force. It's completely in the X direction. So it does not make the box press harder. It doesn't apply an upward or a downward force. That's when you could ignore the applied force if it's not applied at an angle. So we'll leave that alone. So that just becomes the normal force, the up force on the box, which is the normal, equals the down, which is the perpendicular component of the weight force, Fg sine theta. Nope, Fg cosine theta. Fg because we have a weight. Okay. Last box. Now the geometry, I'm going to help you out with this. This is some tough geometry. I'll show you how to do this. You have two intersecting lines. If this is 53, I hope you know that this is 53.13. This is parallel to this. This is parallel to that. So we could also say that this is 53.13 degrees. Okay. So the sum of the forces in the y direction, we want to find the normal, equals 0. The normal acts in the y direction. All right, so there we could say the down force equals, let's do the other. Let's say the up force, the up forces equal the down forces. So the up force is the normal force, and the down force is the perpendicular component of the weight force plus the applied force, 50 newtons, acts its vertical component, sine 53.13, acts to push the box down, becomes a down force. These are two down forces. The perpendicular component of the weight force and the applied force, 50 newtons, acts to push the box down a bit. So the normal force is the only up force. The perpendicular component is 100 newtons cosine 53.13 degrees plus the perpendicular component is also a down force, sine 53.13 degrees. When you add them all together, you get a normal force that is the combination of the perpendicular component. Let's take a look what that is. That's 60 newtons. Yeah, 100 cosine theta is 60 newtons when you work it out. Plus the applied force, the vertical component of the applied force, which turns out to be 40 newtons. Yeah, 40 newtons. And so we see the normal is 100 newtons. The normal is 100 newtons. So I'm doing the same thing each time. Sum of the forces in the y direction equals 0. I want to find the normal force. It's a y force. The up force on this box is only the normal force. The down force is the perpendicular component plus the vertical component it acts downward. The vertical component of the applied force, somebody's pushing on this box, maybe pushing this box upward, or at least trying to push the box upward. Who knows if he or she is being successful? The perpendicular component is 100 cosine 53.13 degrees, the ramp angle, and then the uh, vertical component of the applied force, the force put on this box. When you add them all up, you get 100. And that is the end. I think there's no more of all that I'm going to do here.